procedure and the coding part of the Plaxis between Monopile Designer and of course the Plaxis 3D is completely amazing, and you can see how it's going to be happened. For two kind of material type, clay and sand, you can see Monopile Designer have its own understanding system. For clay has a unit weight, shear modulus, and the shear strength of the top of the layer and the bottom of the layer, and the K0 for the Jackie formula, 1 minus sinus phi. And for the sand, it's a little different. For sand, it's only the shear modulus, friction angle, and PC, and of course the 1 minus sinus phi actually as Jackie formula. So imagine we are going to use as a tutorial for sand. We're clicking on add. The top layer is 0, the bottom layer maybe is minus 10, and the unit weight could be just for sand 18, and the unit weight should be gamma prime, the saturated part, and shear modulus could be maybe 4,580, and friction angle could be maybe 20. So this is enough. I don't want to change anything, but I'm going to, for tutorial system, I'm going to create another layer. The next layer is going to be minus 25. Maybe it's going to be 19, and it's going to be 5,500, maybe 25. So for third layer, I might have minus 35. So the unit weight, of course, could be 92, and maybe 6,000. So the 35 is enough for this specific part of the system. The layer could have different procedure. No, you should only create the defined material parameters with one system, clay or sand. If you want to have different layer under each other, is not going to be possible. So right now we are going to calibrate it. In calibration situation, we have one specific model of monopile. You might need different kind of monopile design foundation, and you can have as much as you want here and create it with all of them. So for a start, I am going to create the GODS one. H is going to be the free part of the monopile. I choose 10 meter. The L is the embedded beam part. I choose 25 meter. And maybe 25 is too much. 25 from the top, that means here. And it's enough. It's not that much enough for the last layer to have the interaction part of our monopile system. I think maybe it's for besides minus 35, you could use minus 65. It's going to be better and a deeper layer. Let's back to the calibration system, and the out is the out part of the diameter of the pipe. Maybe 1 meter is enough. That is the diameter, diameter of the thicknesses of the plate you are using for the monopile system. Maybe 0.06 could be enough. Which on the out is a specific coefficient to give you the understanding the system how it's going to be optimized itself. So for this one, I just use 0.25. But how it's going to be exactly calculated and what is different, you can follow our system in the next videos. So for the next one, it could be like this one, but I don't need it, so maybe I delete it just for this part. I just want to have one layer, okay? The GODS1 is our first system. We want to talk about it. The area is completely calculated itself. Moment of inertia is calculated itself. EA and EI also is calculating itself. But and in the end, the GA, the area multiple to the system of the shear modulus is actually calculated itself too. But for structural properties, unit weight is here, and the Young modulus is 210 in E6, and the Poisson ratio is 0.3. So let's generate the system. For this one, Plaxis 3D automatically going to open itself and create whatever order you are creating inside the system, and going to moving inside it, and every coding Python system going to be appear right now, and it's going to show it to you. Just give it a second. Maybe some errors going to appear inside this generation. In the tutorial, I need to create these errors for you to solving it, and not always all the procedure might have been successful. But right now, invalid values for the parameters in the solid model, please correct them into continue. On layer 1 to 3, the value of the smallest shear modulus is outside the allowable range. Please use a GODS1. So what does that mean? I need to adjacent of the system of the shear modulus, and new numbers of the shear modulus should be appeared here. For this part, for changing the number in the end, you should be able to fix whatever the shear modulus is needed. So maybe the changing the number in the right range of the stiffnesses is more necessarily. I change the number into 60,000, 70,000, 80,000 kN per square meter. So for continuing, I back to the calibration. I will add a new layer. What am I doing with this new layer? In this new layer, I want to change the system. What should I do? For this one, I'm using the different part, and different part means different calculation. So for here, maybe it's 0.1, and everything I want to be the next system. What should I do again? I need to generate it again for the new one. Ignore feedback, the following models will be regenerated. Any manual modification to these models may be completely or partially lost. It's not important because I'm curating the model from the previous model, and this part is not that much important, guys, so be careful. For this part, just change whatever you want and you might have a new regeneration. In here, the regeneration will be creating itself, and you can see the jumping part of the Plaxis 3D, like this. Right now the Plaxis 3D automatically going to open itself, and it's going to create the whole model in 3D version and prepare itself for calculating it. What's happened in here, you can see the whole model history coding part is creating based on whatever you are introduced inside your first part of the system. The interfaces and creating all the procedure is going to be automatically reading from the output of the Python code, created coming completely from the MonoPy designer system. Now directly importing itself inside the Plaxis 3D. I will wait for the mesh generation. After the mesh generation, the system is going to jump into the stage construction procedure. Right now, the output of the mesh generation going to give you the points and the movement of the procedure should be noted, and it's going to automatically update it itself. Now the soil system initial phase, pile wished in place, the small displacement and large displacement, all of them is creating itself. So in the end, I have two procedures completely creating itself separately. What's happening here? The next step for both of them is calculating part. This part is going to calculate itself completely. Automatically open the previous file and start to calculate the monopile system under every specific part of the loading procedure the Bentley Plaxis introduced into the system. You can see the initial phase is done. After that, the pile wished in place part is going to give you the understanding the stresses come from the pile installment procedure. After that, a small displacement from the movement of the part and the piles and the load system is appeared itself. And after the small displacement, the large displacement also will going to appear itself to calculation phase for understanding better the bigger load movement. And you can prepare yourself to completely compare them with each other. As you can see, this part, the M stage part, is completely show itself. The 60% of the construction movement is completely added to the system. The way of the loading, the way of the actual loading procedure, and the displacement and the movement procedure is all appeared after each other automatically with Python tool. Which this part, the Python tool, do not be created with anyone else. Just you needed to do it with MonoPy Designer. Now in Sigma M stage, in the large displacement procedure, you can see the movement of the Sigma M stage is a little slower and with a small increment of the load values and the values of the system of the construction and the percentage of the advancement. Why this happening? Because the system of the FX is too much and for the large displacement, so the movement is different, and you can see the nodes is also creating itself automatically, and maybe in the end we can find out what do we have here to work with. After the calculation is got finished, it's going to close itself automatically, and you can see the GeoDS2 is completely calculated itself. Now the right part, we have monopile response for this specific model. Large displacement system, soil reaction part, shaft depth procedure is not calculated, and the base depth variation function is also not calculated. What should I do with them? You should go through different parts of the calculation part, and these outputs, all of them needs to be analyzed and completely be understanding. And actually, of course, you can go into the Plaxis 3D itself. When you are going to Plaxis 3D itself, you can get a lot of output and changing the loading and whatever you want. What the output is not going to directly import itself in the MonoPy Designer. So for the numerical system of the MonoPy Designer, you finished it, but the export to SACS and everything as analyzing part is going to start right now.